In this example, we're going to graph the function 4x squared minus 3x minus 1 over x plus 2. First thing I'm going to do is factor the function, and I notice the top can be factored. So I'm going to go ahead and write it in factored form. So f of x is equal to, now in the denominator I'm going to have x plus 2. In the numerator, I'm going to go ahead and open up two sets of parentheses, and I'm going to do some guessing and checking because I notice that the last term is negative 1, and there's only two factors of 1, and that's 1 and 1. And one of them is going to have to be negative, and since the 3x is negative, I'm going to make this minus and this plus. Let's see if that works. So 4x times 4x is 4x squared. Outside times outside is negative 4x. Inside times inside is positive 1x, which would give me negative 3x. And 1 times negative 1 is negative 1. So that is the factored form of the function. Moving on to domain. So for the domain, remember you set the denominator not equal to 0 because that's a value of x that it can't be. So that means that x cannot be negative 2. So that means the domain is everything but negative 2, which I write like this. Now moving on to x-intercepts and y-intercepts. So the x-intercepts come from letting y equal 0. And in a rational function, you can just set the numerator equal to 0 because a fraction is 0 when its top is 0. So I would have 4x plus 1 times x minus 1, and I want to set that equal to 0. So 4x plus 1 equals 0. 4x equals negative 1, so x is equal to negative 1/4. So one of my x-intercepts is negative 1/4, 0. I have another one, x minus 1 equals 0, so x is equal to 1. And then finally, let's see if there are any y-intercepts. So the y-intercepts come from letting x equal 0. And I like to do that in the unfactored form of the function because all the x terms will go away and you'd be left with negative 1 over 2. So f of 0 is going to be negative 1 over 2. So that's going to give me 0, negative 1/2 as my y-intercept. So for wholes, I look to see if there are any common factors in the top and the bottom, and there are not. So there are no wholes in this function. But there is a vertical asymptote because if you remember, x can't be negative 2. So there's either a whole or a vertical asymptote there. And since there are no wholes, no common factors, my vertical asymptote is x equals negative 2. And then horizontal or slant asymptotes, remember you look at the degree. So the degree of the numerator is 2, and the degree of the denominator is 1. So this one is top heavy, which means there's going to be a slant asymptote, because when things are top heavy, they're going to pull you over or make you slant. And to find that, we need to divide. And in this case, our denominator is in the form x minus c, with c equal to negative 2. So I'm going to use synthetic division. I'm going to put negative 2 in my box. I'm going to list the coefficients of my polynomial, which were 4, negative 3, and negative 1. So I have 4, negative 3, and negative 1. Now I'm going to bring down the 4. Negative 2 times 4 is negative 8, which gives me negative 11. I really could stop there, but just to finish this out, 22 minus 1 is 21. Remember, we throw away the remainder, and this is the slope and the y-intercept of your slant asymptote. All right, so let's go ahead and do a little graphing with the things that we do know. So we know that we have a vertical asymptote at y equals -2. I'm sorry, x equals -2. Getting everything backwards now. I think I've done too many of these in a row. So I'm going to label this as my vertical asymptote at x equals -2. I also have 3 points that I can graph, so I'm going to switch to blue because those are a part of the graph. So I have -1/4, 0, which is about here. I have 1, 0, which is about here. And then because my slant asymptote is y equals 4x minus 11, and I graphed this one before I actually created the video, and I know I'm going to make my y-axis be scaled by 5. So -5, -10, -15, -20, -25, -30, -35, -40, -45, -50, 5, 10, 15, and so on. So the point 0, -1/2 is really, really close to my x-axis. All right, so now let's graph your slant asymptote. So I'm graphing the line y equals 4x minus 11. So that means my y-intercept is -11. We can't forget how to graph a line, right? And my slope is 4/1. So I'm going to start at -11, and from there I'm going to go up 4/1. So I go to the y-axis, I'm going to go down 5, 10, -11 is going to be somewhere around there. Sorry, I'm trying to get this off and I'm not exactly sure. There we go. And then from there I'm going to go up 4/1, up 4/1. And so it looks like my slant asymptote is going to look a little like this. All right, so I know I have something over here, and it looks like this part of the graph is going to come through here and follow that line and come up here and follow this line. And I think I did find one other point. So let me create my table of values. When I plug in x equals -1, I actually get 6. So let me, so -1, remember they're going up by 5, so 6 is going to be somewhere in that vicinity. So it's going to come up like this. All right, now this is what's crazy. When you plug in values to the left of x equals -2, I used -2.5, and you actually get -59. I used -3, and I got -44. And I used -4, and I got -37.5. So I'm glad I made these numbers a little bigger. So let's see, -2.5, -59 is still going to be off the graph somewhere about here. And remember, with points that aren't on the coordinate plane, you do need to list their coordinates so the reader knows what they are. So sorry, this was -2.5, -59. Then we had -4, I'm sorry, -3 was -44. So that's going to be about here. And then -4 was negative 37.5. So that's going to be somewhere in here if I'm graphing that correctly. So it looks like this one's going to come up this way and follow along that line and come down here because this vertical asymptote would continue going down in this direction. And that's the graph of the function.